Unit 3, Lesson 5, and we are going to learn how to create variables. So, the first thing that it asks us to do is to read the code below and make a prediction. Where will the circle be drawn? And what will happen if you change the number in line 1? So, looking at this, and if I put again, I'm going to put on my I'm going to turn on my grid. What do we think is going to happen, guys? We are just making a prediction. Where do we think it'll be drawn, and what will happen if I change the number? So it'll be drawn where? Right, but where? Like at what location? Like give me a XY coordinate system. Okay, top left is fine. Okay, and then what would happen if I change the number in line 1? Line 1, variable x position 50. What's going to happen if I change this number? It'll move. Okay. What do you need? Okay, cool. All right, so I'm going to go ahead. Okay, so it's actually in the lower left-hand corner. And then if I change the number in this code here, what do we want to change this to? Give me a number, anybody. 20. Awesome. Come on. Oh, it's not letting me change it either. There's probably a bug in the code. Okay, anyways, we'll find out what happens. All right, so I'm going to go ahead and finish on that. I'm not worried about the bug in the code. That's just a prediction, guys. All right, so we are going to learn about variables today.
Most apps keep track of pieces of information that change and update as you use the app. For example, a simple game can keep track of your score and the number of lives you have left as you play. Apps utilize the computer's memory to do this, and learning how to use that memory when programming is a really powerful skill. The most common way to leverage a computer's memory is by creating a variable. Now, a variable is just a container for storing a value. And once created, the variable is stored in the computer's memory, and it can be used and updated repeatedly throughout your program. As an example, let's use variables to keep track of the score and the number of lives remaining in a hypothetical game. Creating the variable is really easy. You use the word var followed by a label that you want to give the variable. You can choose any label you want, but it helps to choose a word that describes the variable that you want to store. So let's label our first variable score to keep track of the score. And then we can create a second variable to keep track of lives. Remember these labels. You'll need them later in order to use the variables. We can assign a value to the variable using the equal sign, like this. Let's set our starting score to 0 and our number of lives to 3. Remember, you only need to use the var at the time that you want to create a new variable. A common mistake is to use it every single time you want to refer to a variable. Also, be sure to avoid mixing up the order when you call your variable. The label's got to appear on the left, and the value has to appear on the right, like this, not like this. Often, you'll want to create a variable and assign it a value right away. There's a really convenient way to do this with one line of code. This is sometimes called initializing the variable. It's important to realize that this single line of code is actually doing two things. First, creating the variable, and then second, assigning it a value. Let's take a moment to talk about the equal sign. In many coding language, the equal symbol is called the assignment operator because you use it to assign a value to a variable. And you're probably used to seeing it in math, but in programming, it's a little bit different. If you were in math class and you saw this, something would definitely be wrong. Score can't possibly equal both 5 and 7, but this is not math class. With code, a computer is executing a set of instructions, one after the other. So this would just tell the computer to set score to 5, and then on the next line, set it to 7. In an effort to avoid confusion, programmers often don't use the word equals when we see this sign. Instead, they use the phrase gets the value. So when we see a statement like this, we could read it as score gets the value 7, or score gets 7 for short. Some programming languages avoid the confusion entirely by representing the assignment statements with a sideways arrow, like this. To use a variable, you just refer to it by its label. Anywhere the variable name appears in the program, the value currently stored in the variable will be retrieved from memory. The tricky part is that when using a variable, you often can't see visually what its value is. To bypass that problem, you can use console.log to display the value like this. This is a really handy trick, but remember there's a difference between showing the value of a variable and writing out the variable's label. When text appears in quotes, you're telling the computer to write those literal ASCII characters on the screen, like this. But on the other hand, without quotes, the computer assumes that you're referring to a variable called score, and it will attempt to retrieve its value. If you haven't made that variable, then the computer will give an error.
All right, so yay, variables. All right, so again, all a variable really is a container that holds a value that you're going to want to use over and over and over again. So instead of having to retype it every single time, you just have to type the label. All right, moving on. So let's go ahead and take a look at, I want to say bubbles 3, 4, 5, and then 6 is going to be on you. All right, so again, in which corner will the circle be drawn? Ladies and gentlemen, what are we thinking? I hear top right. Let's try that. All right, it is on the top right. Again, because my x position is 300, and the variable what is the y is 100. So I created variables for that position. So anytime I wanted to use 300 and 100, instead of writing 300 or 100, I'd have to put these names in. Now, to me, that's a little silly, but it's whatever. All right, cool. No, that's part of my program. It really kind of does because I'm just that happy and peppy. All right, so debugging variables. So naming variables. This program has multiple errors caused by bad variable labels. The errors prevent the program from being viewed in block mode. So the code is in text. Below are a few rules for naming variables. Clip helps and tips to read more. Number 1, labels cannot have spaces. Number 2, labels cannot start with a number. And number 3, capitalization and spelling must be exactly the same. All right, cool. So I have var size of circle. What is wrong with that one? I have spaces. So again, no spaces are allowed. If you want there to see space, feel free to use underscores instead of actual physical spaces. All right. Line 2 of the code. Var one dimension. Take out the 1. Now, it might be there for a reason, so I'm actually just going to add it on the backside. You don't necessarily have to do that, but I'm sure there's a reason they put the number in there. And finally, var y location. Yep, when they come down here later, they capitalize it. So I'm just going to capitalize it here. And it doesn't matter. You could lower score it underneath. It wouldn't matter, but they just have to match. All right, cool. So now I'm going to try to run it. Oh, and it still won't run. Why? The spaces. So now I have to actually fix the spaces underneath so that they match. Again, everything has to match perfectly. And then I need to fix it again. Size of circle, underscores. All right, so now it looks like everything matches, I think. Oh, no, it doesn't. I need to change this one. All right, so now all of my variables look like they match. I can tell because all of my little warning symbols have disappeared in my 6 lines of code. If I go reset run, it should appear. Now that it's running, I can go to show blocks, which is most of my students' preferred way of looking at code. But you cannot see the blocks if there is a mistake in your code. All right, so look at where it says var size of circle. Go to line 6 and make sure size of circle has all of your underscores. Var y location. So did you go down into line 6 and fix it? There should be no spaces. You cannot start a variable with a number. You need to make sure all your variables match up 100%, and you are not allowed to have spaces in your variables. Those are your rules. The commas are just saying go to the next variable. Yeah. And I will make mine a little bit bigger so it's easier to see. So not only are you fixing the top, but you also need to fix the bottom. Oh, there was an extra space in there. All right, anybody else? You have to fix it up here as well. So now those match these guys. You need to make sure you take out that extra space.
So wait, but they had said that this one was wrong. So what am I
We'll go through them one at a time. Okay. Okay, so you're not allowed to start with a number. I'm going to throw the number to the back, and then I'm going to change it down here. So now those guys match. Y location, reset and run. One dimension, Y location. Oh, size of circle, there's an extra space. There you go. All right. Anything else? Okay, cool. So we're going to go ahead and finish bubble 4. Okay, then come see me. Okay, so your variable up here and the variable down here has to match. So if you took all the spaces out, then you have to take them out up here too. Because this is where you're naming it. Do you understand? So whatever name you give it here is the name you're going to use down there. So same thing here. Dimension 1, that says 1 dimension. So go ahead and change that one. And then the other one looks good. There you go. Perfect. All right. Bubble 5, ladies and gentlemen. So change the sign petal size. Somebody close the door, please. All right. So I'm going to go ahead to blocks because I prefer blocks. If you don't prefer blocks, you can work in text. That's perfectly fine. All right, so when I run this program, my petals are not overlapping. And if I look at my instructions, the goal, it says try to find a size that makes the most sense so that the red petals touch each other. So there are 2 ways you can do this. You can go through and change every single petal, or you can just change the variable. So I'm going to change this to 25. It's not going to work, and I know that. Reset, run. Okay, so they actually got smaller. All right, so give me a number that might make them overlap. Try 100. Okay, we could try 100. All right, reset, run. All right, cool. Uh, that's fine. Do we want to try a different number? 30 will be too small. It has to be bigger than 50. Huh? 65. Not quite touching. 80. All right, we could try 80. All right, cool. Anyways, you get the point, guys. I changed that one number and it changes every single circle that I created, right? That I use that variable name in. Now, technically speaking, I can go and change all of those lines of code if I wanted to, but it's kind of like, why bother? It's a lot easier to use a variable. Remember, a variable is just a container that says, when I put this word in, this number is going to appear over and over again. So instead of having to write 85 8 times, I could just do a copy paste on petal and then create one petal size. All right, so we're going to finish that one. All right, ladies and gentlemen, on bubble 6, this is for you to do. You have A through D. Changing and then 3 debugging activities. You will also have to complete 7, which is a make it work kind of a thing. So you have a picture and they want you to basically, recreate that. And then as always, number 8 is the challenge. These are 100% optional, but you are welcome to try them. As always, if you have any issues or questions, pop on up and see me. Other than that, you have the rest of the time to work.